Hi, it's Gadget UK here again, back for another A500 repair. The series that just never ends and keeps on giving. So this board came thanks to William, the chap that donated the Atari Falcon. You can see straight away, you might be able to see that there, green pin, so we need to take that out and have a look at that socket, I think, and just clean up the pins on that chip. That's Gary, Paula, CA, Denise. We've got a missing ROM, we've got the 68K CPU in there. And we've got an 8371 Agnes. That's the original PAL version. If you've got an NTSC system, it's going to be an 8370 there. Later, we went on to the 8372 that shipped on like Rev 6 boards. That gives you up to 1 meg of chip RAM. So this, the 8371, 8370, you can only address half a meg of chip. The interesting thing with this board, despite the fact it's got an old Agnes, it's actually a 6A. So you can have the extra chips here, and it's got 4 chips there, giving you half a meg, so you could upgrade this to 1 meg. But if you do that, as I mentioned previously, you disable the slot over here without further modification. And I'm not just talking about changing a few jumpers, you need to add some 7.4 series to address 1.5 meg. We've got a bent pin here, can you see that? That's shorting. Maybe that's the issue, I don't know. So we'll strain that pin and let's get this out. Let's just try and just see if we can just lift that pin upwards away from the other one. You could argue, test it first, see the fault, and then do something about it, but you know what, this could be just a result of transit, and we may create a second fault by not straightening that up. Well, it's not a case of straightening it, it's just pulling it away. There we go, from that other pin. I'll straighten them properly in a minute. Down here is a bit bent as well. Anyway, let's just get that Gary out. Yeah, it's just a little bit greeny, that, which is a bit strange. I wonder if it's come from an A500 Plus, maybe. Anyway, I'm going to go clean that up with some vinegar first, I think, and then the fiberglass pen. The socket, however, looks perfect. So let's just get a little bit of vinegar on here. Be interested to see if it fizzes at all. Nope, no reaction. Well, there will be a reaction, but no sort of fizzing up type reaction. So I'll just give that a good scrub in here. And then I'll get the fiberglass pen onto it. And we'll finish off here just by gently going over the pins with the fiberglass pencil. So let's get Gary back into his socket. Obviously I'll clean the socket up on the chip again later, but I'm pretty sure that socket is okay and that is not the cause of the issue. So connect sound and video and stuff. So just doing a sense check around the board, everything else looks okay here. Obviously we need a ROM. I'm not convinced the pins there are right, actually it looks like we have some pins missing. Yeah, we could have a pin missing here. I'm going to try it with Logica, I think, actually. Just because I don't have diagram nearby. Is that the right way up? Yeah, that's the right way up. So let's get power and let's try that. So let's see what happens. Switch it off again. That's interesting. So it's like it started to boot and then went off. I'll cycle the power again. I'm just feeling the tops of the chips here as well. Yeah, see, so it started to boot and then it went. Oh, hang on, it's actually starting to boot that one. Hang on a minute, it might be the Agnes. Let's just press onto Agnes here. No, there's definitely something going on. There may be nothing wrong with it, but the pins up here just look a bit weird. Like, as you look down each hole there, you can see a bit of silver. On those N3, you can't so much see anything. There we go. Yeah, this corner here. So, just looking at those pins, can you see the ones on the left hand side? They look a bit weird. The other pins look alright, so I think what I'm going to do is just use the multimeter probe, a bit of magnification, just see if I can work out what's going on there. Kind of looks black. Is that plastic or something over there? I don't know. Can't really see what's going on. I think it's just the way they're bent. Oh, hang on a minute. I was looking with the magnification. It's dead obvious what's going on here. Look. Socket. It's hanging to pieces here. We could probably pull that piece of plastic off. Obviously I'm going to swap this, I wouldn't just glue that. So yeah, you can see what I mean, these pins here, they bend backwards, so if we just bend them inwards a little bit, and if we stick the chip back in, it's going to make a better connection. Certainly these N2. That's a bit better. Let me just make sure there's a stray. Yeah, they look stray. So pin 1 is over here. Let's just get that back in. Of course this side might be loose as well, that could be the problem here. Yeah, I can see those now. Oh, pressing I think on there. Yeah, that's pressing. So let's try that. Yeah, there's more than just that damaged socket going on here, I think. Hang on a minute, look at this side here, this side's damaged as well. So, yeah, there we go. I'm not going to be able to get that out now, am I? I'm going to have to prise it. So, I mean, you're going to see it move now, because look, yeah, it's broken, look. This whole end here is hanging off. The big problem now, because I've not got the corner here, I never thought about this, is the implications of how do you lift it out with this. See what I mean? It's like, I can lift it this way, maybe. There we go, it's coming out. So yeah, we've got exactly the same problem there. I guess it's worth just inspecting these pins as well. They look alright actually, I think. So yeah, we've got the same problem here. This end is sort of hanging on. Let's get the board out of its shield here. God, it's quite stiff. And then we'll replace that Agnes socket. The ROM socket really needs replacing as well. Before I pushed the that ROM module there in, it had normal socket below it with you know, thin pins, not round ones, and it wouldn't stay in. It was just literally falling in and out, so it's had round pins in it at some point. And yeah, that's the reason that socket needs replacing. So the easiest way to get this off is using the solder station, but I'm just going to use the solder socket here actually. I'll just do these at a pin at a time. The engineer pump here, you can see, frees up the solder really, really well. Just occasionally you might need to add some flux. So that's free. That's free. So I've desoldered all the pins here, the ground and the power. I just used the second iron at the same time as the desolder station. There's no way you could do those probably with the engineer pump that I was using and the Heiko. You could perhaps set the Heiko higher. You can see I'm just you know, grabbing 2 or 3 here, pivoting just to snap them off. I've inspected around here a few times. Everything looks free, to be fair, but some of these are still going to be holding on just a little bit from the other side. Just flip that over. Let's just have a little bit of a wobble. There we go. So I just desoldered a little bit more from that side and then just leave it up. And can you see here as well, look at the dirt around there. So yeah, that was just down here. Anyway, looks okay. The only thing I will do is just you know, go lightly over the top here with the fiberglass pen, clean it around with a bit of IPA, and we'll get the new socket on. Obviously, inspect with magnification. You want to make sure these connections are all good and you've not broken any traces or anything, or missing any pads before you solder the socket on. There's our replacement socket. I hope that's the right size it looks at, I think. Yeah, that should be right. So pin 1 is here. So pin 1 on the chip is there. It's going to go that way because there's a slice here, I think. Yeah, pin 1 marking is there as well. So that's correct. So it's going to go that way, like that. There's something up here not straight. Yeah, just a few pins. There we go. So I just need to just flip that over and solder it on. So I'll just anchor a couple of pins here actually. One there and one over here. And then I'm just going to press it and reflow. Yeah, you could hear it move then. Right, that's it. That's our Agnes socket replaced. I'll clean up with some IPA and stuff in a minute and a brush. Let's just flip this over and let's get the Agnes back in. So pin one towards the right here. Nice fit. Let's go and try it. And let's switch it on. Yep, that's looking normal, I think. Although the green and black flashes weren't very long. Yeah, that's booting anyway. That's the main thing, because this was not booting at all before. I could just about get it to sort of half boot by holding the socket in different orientations, you know, putting pressure on it. Anyway, the next thing I need to do is connect a keyboard. Let's do 2 memory tests. Let's do chip mem. In fact, that's not the right test, it's extended chip mem. There we go, so let's let that go through and see if the RAM's okay. The interesting thing is we got an address error detected right at the end of the memory test. It did test all of the RAM though, it didn't test all 512K. So there is something strange going on with this one. So I noticed the RAM test would fail if you just put a bit of pressure on the board. Now, I'm just going to clean around here just for some good measure really. I don't think the socket is corroded, but let's just rule it out. I'm just using a bit of IPA here. If there was corrosion, I should use vinegar and then IPA. Rinse it away, you know, dry it off and all that. But yeah, I just want to rule out anything there being a bit bad connection. Wait for that to dry, and then I'll fit the chip back in and we'll try it again. But literally just putting some pressure here gave some exceptions on the RAM test. So we could have a broken trace somewhere around here. It could be a bad connection on the Agnes, but I don't think so. The socket is really good. The Agnes looks pretty clean. That's a good point actually. I didn't clean the sides of the Agnes. Maybe we should do that. Anyway, we'll let it dry before we test it again. Yeah, I managed to get an exception again there just by touching the board lightly. So we'll just clean around the Agnes here, and we'll also clean the 68,000 pins as well. They look good as new, those. They've got a nice solid coating on them. So the Agnes is back in. I'm not sure if I cleaned these before. I'm getting deja vu here. I think I did. I think I did clean these. Maybe I'm thinking of Gary. Some of the pins here look a little bit dark. Pin 1 is down the bottom here. So let's get the left side first and then push that back in. Right, let's try that. So not really getting anywhere with this. It's a bit strange. I've swapped over to an 8372A. I'll show you there's a weird touch sensitive issue with that other Agnes. You can just literally put your finger near it and the screen goes weird. It goes crazy. The video goes weird. Now the interesting thing is with Logica, you just get a white screen. You know, it goes through the coloured tests and things there. It's just about to finish the test and then the screen just goes white. So you can't get any further with Logica. It gives you no diagnostic information other than a white screen. I've done a bit of research because I thought, I wonder if there's something else going on. I did wonder if it was RAM. You know, this is why I swapped over to Logica. I thought, I wonder if there's a RAM issue that Diagram can't find. Because the thing with Diagram, you can go through all the tests and everything works. Every single thing works fine. There are no issues. Yeah, it won't boot with Kickstart. It's just you get a white screen on Kickstart, coincidentally. But anyway, a white screen in Logica means there's a VBlank issue. So that might be the clue here. If this is saying there's a problem with the VBlank, maybe there is. Maybe Diagram can't detect that for one reason or another. So where does that leave us? Well, I think the first thing I'm going to do is reseat Denise. I'll show you the error first, actually, before we do that, because that's the only chip. Incidentally, that is the only chip that's not been reseated yet or replaced. I swapped Gary and Paula, same behaviour. Swapped the CIAs around, same behaviour. We've swapped the Agnes here, same behaviour. It's definitely not the ROM. It's not the CPU. I've swapped that CPU as well, same behaviour. I've logic to probe the OR gate over there, the 32. To check the chip selects are okay for these CIAs and they are, because it seems to be freezing at the point where it should boot the floppy drive. You know, you got like dark grey, light grey, white, nothing. Never comes up with a sticky disk in screen, never hits the floppy drive. But thinking about it, if there is a problem with a VBlank, maybe that is the issue. Maybe Kickstart is running some code that's VBlank, waiting for the VBlank, and it never occurs, so it just sits there looping forever and a day, waiting for the VBlank. That's a possibility. But then you think, in Diagrom, you think there'd be code there that needs the VBlank. So maybe it's done a different way, maybe it's not bothered about the VBlank. Maybe none of the tests there check the VBlank. I don't know. Anyway, we'll reseat that, but I'll show you the error first. So switch it on. So this is all normal. These bands and things and flashing and stuff here is all normal. It's all part of the memory test that this runs on startup. That's correct, I think. That isn't. It just sits there on a white screen. It never comes back. The other thing I did here is flip the board over and logic probe all of the pins on all these socketed chips to make sure that the signal is there. You know, you've not got like a floating connection on the socket that's not coming from the chip, you know, because as a result of the socket. And the sockets are all alright, so... And just the fact that all these things here have been reseated, yeah, it's not the issue. Well and truly stuck in on one side, look. Maybe it is about the socket. Well, the pins look alright, don't they? And the socket does kind of look alright. Maybe this cap's leaked and there's some corrosion around here that means the VBlank signal's not getting through or something, I don't know. Does that look like that's been reflowed? Hard to tell. Anyway, let's just reseat it and see if a reseat makes any difference, and then I'll swap it. And of course the next thing to do is hit the schematics. Now look, white screen again. The next thing to do is hit the schematics and try and work out what might be affecting the VBlank. I don't know. Anyway, I'm going to swap that chip out, bear with me. So I've swapped Denise over. Let's see what happens there now. I'm expecting no difference, to be honest. Nothing else has made any difference so far. Yeah, just the same. Right, finally I've made some progress. The first thing I'll point out is I tested the 8371 on the other 6A board and it won't boot at all with it, so that Agnes is not working on the other board. It does work on here, and I'll show you that later. You can just hover near it here like with your finger and then it glitches out. So there is a fault with that other Agnes, but that is not the issue. I've been round everything here. I was looking at the V-Sync because obviously with that white screen there giving us the clue. I think that's a red herring. You know, this is the thing. You've got to be careful when with the results of these tests in terms of how you react to them. Check the things obviously that it points out, but bear in mind you can get red herrings. Something can be reported as a fault when it actually isn't. Now the interesting thing I thought, let's just try the theory that because the floppy drive doesn't work, although the keyboard works, the floppy drive doesn't work. We know it's not this one. Let's just try it without this, and actually it boots, as you can see here. So, what do we make from that? I don't know. Well, obviously we haven't got keyboard input now. I'm not sure mouse will work actually either. It might go up and down, it might not. Oh, it does work. The mouse works. That's interesting. The mouse goes through U7, so that makes sense. Keyboard's not working at the moment. So we can go up and down. It's an A500. I'm amazed it's working though. So what this tells me is it's perhaps a chip enable. Maybe the LS32 on here is the problem. It could be this simple. I mean, the thing that's strange about that actually is if it was the chip select, how on earth was Logica passing all of the tests for the CIAs, the specific timers? That's the weird thing that I don't quite get. But anyway, we've made we've turned a corner just by removing that CIA. So let's do the memory test. This was the whole intention of running this here actually. Chip memory test. Just to rule out the RAM. I don't think it's going to be the RAM, to be honest. There we go. No errors. So the chip RAM is okay. I'm just going to try the same thing with the fast RAM connected because that was giving me an interesting thing when I was trying to do a manual memory edit. So I just tested the fast RAM there and that passed okay as well. So let's test it with Kickstart now, just see if we get a sticky disk in screen when that CIA-B, the even CIA, is missing. Right, so we got Kickstart 1.3, is it? Or it might be 1.2, I'm not sure. Anyway, let's see what happens with that. Come on. Yay! Fantastic! So there we go. That is what it is. That even CAA seems to be causing the problem. So my attention has shifted now. I think I'm going to I'll test the connectivity around there to make sure we've not got a missing trace. But it's looking like the chip select perhaps for that CAA. So again, this could be a red herring because you know what? I've checked all the connectivity around this. A12 and A13 go there correctly. The signals go out to the CAAs. I've checked around the connection of U7. I've checked the connectivity all around the CAA in question, and that isn't an issue either. So I don't know. I mean, I've tried piggybacking this. No different. It could be that it's. I don't know. I honestly don't know. I'm going to remove it anyway. I'm going to remove it, socket it up, and just rule it out because it is a fairly obvious possibility that maybe its timing is slightly off. It's I guess I could scope it, but you know what, it's going to be easy just to pull the thing off and socket it, I think. So is this going to fix it? I don't know. Right now I'm like 50-50. Yeah, the solder's not coming away there. I think this is maybe not warm enough. Let's just add a bit of solder with flux. That's a bit better. Still not freeing it up. Gotta go a bit higher on the temperature, I think. I may just free this with some hot air in a minute. Yeah, it's just, the heat's not travelling through at all. That was surprisingly painful. I bet there's loads of solder on the other side still. Yeah, looks like it's not freed that up at all. Look, there's hardly any solder gone from that side. This is what I hate about A500 motherboards. There are a few caps here, got to be careful not to get too near those. There you go. It's off. So believe it or not, the final piece of the puzzle was this CAA. I've swapped this CAA. It was got nothing to do with the chip selects here. What I don't understand is I tested these under the board and they were alright. So I actually think if I test this on the other board, it's probably going to come up okay. I'm going to do that next. There's something marginal on it. Maybe one of the pull-ups or something. Where when it's in this board, that marginal issue means it doesn't work. You stick it in the other board and it does work. So I think that's what the issue is. Obviously I'm going to inspect a bit more closely, check the resistor packs and things around it just in case there's something else causing that fault. But I put the original Agnes back in just to show you the behaviour. Just watch this, it's crazy. Now what's probably caused this was the damaged socket. If I was to guess, listen, it's booting. And it's gone. You see the video there go crazy. Now the interesting thing is, if you put it back off and on, it won't work generally. Yeah, it's not coming back on now. If I put my fingers over the top of the Agnes and switch it back on, the capacitance that I'm providing, it's not doing it now. So I'm going to power it back on now. I've just got my fingers on top of the Agnes. Interestingly, that's the same behaviour we had with that CAA, wasn't it? I can't help but wonder if this Agnes is the thing that killed the CAA. Maybe the H-Sync, or, well yeah, it would be the H-Sync on that chip, the V-Sync is the other one. But I think maybe the H-Sync has messed it up. That is totally possible. It may also explain why when I tested the CAAs previously they were alright. Of course we could damage this CAA with the chip in here like this. I'm just going to rub around it. This is the weird thing, you rub around this, and Stephen Leary's pointed this out before. Sometimes you rub around a chip like that, look, you influence the behaviour. And it's like the static. Look at that. Okay, back up there then, hang on. It could be a bad bond wire or something, you know, because actually, let's just try pressing on it. Yeah, my finger's on the left hand side of the chip here now. Trying not to move. See, it's booting. And that is me just sort of, oh, it's going again, coupling some capacitance or something. That's what it is. It's the effect of my body being next to it. So I thought it was worth just covering why I targeted that LS32. I logic probed the chip select pins. You can see it there. Sorry, I've got the jitters a bit. Is that 22 or 23? I forget the pin number there. But yeah, you can get these schematics online. These are for the R6A or Rev 7. But nevertheless, I logic probed those. Now I could see activity here, and I saw literally no activity there. It's one of those things. I had to use the scope there and you know, set a trigger and captured. I would have seen some activity, but at the point the problem was going wrong, it was this CIA, not this. You know, and this is the thing, you can be chasing a symptom rather than a cause. In other words, you know, the chip select is driven properly here. We know that the LS32 was okay, and it was you know, controlling this chip, reading something somewhere. Maybe floppy related, it could have been IRQ or anything really, but something was going wrong with this CIA. Yeah, we'd swapped them over previously. That hadn't resolved the original issue. The original issue was the Agnes socket and perhaps dirty Gary connections as well. But at that point, you see, I'd swapped them around. I didn't think to, let's just swap them around again to see if we get any further. Now we've resolved those other things. So yeah, there were multiple issues. Didn't need to swap the LS32 or HC32. Well, it says LS32 there. I'm not sure if they've got HC32 on, but anyway, it's always useful to have things like that socketed. We didn't damage it or mark the board in any kind of way, so yeah, it's just got an additional chip socketed. But had I swapped those around at that point, I could have got a little bit further with that and saved myself that swap. Yeah, so some of the waffle there was incorrect about the VSync stuff. Although if you look at VSync does come into the tick pin here. And this is what, you know, why I was thinking CIA's regards to the VSync. So yeah, it's interesting that one goes to U7 and the H-sync here comes into U8. It provides the tick for the time of day things on both of those. You know, it's like timer related stuff, isn't it? Without those pulses there, some of the functionality doesn't work properly. So I can't see it making any difference at all, but I'm just going to go and tin up the pins here, actually, because heating these, I don't know if there is a bond wire problem or something. You never know, heating it may do something. It probably won't. I think it's a fault internally. And as I say, the clue is, when it is working, you can just put your finger in like that, and it goes. As soon as you do it, you can, you know, or sometimes if you push your finger on it, it comes back. And if you hold your finger on for, not pressing really hard, just touching it literally, for, you know, I mean, I managed to boot the entire game up a minute ago just by putting my finger there. As soon as I took my finger off, it went off. So yeah, I suspect this has, you know, suffered some sort of failure. Maybe the H-sync output on here killed the CIA, possibly. So the interesting thing is, after tinning up the sides of that chip and cleaning it off, and obviously it got very hot, it's now a bit better. It's more reliable. You can see what I mean here. Can you see that? It doesn't do the graphical distortion thing. It actually boots but freezes at various points. And more often than not, when you power cycle it, it just starts again. It wasn't doing this before. So temperature, that's frozen. Temperature clearly has a bearing on this particular problem. It's definitely more robust. Oh, it's going, look. You could see little glitches, just a little bit there then. And it's gone again. So late last night, actually, I worked out what the final issue with the Agnes was. I'll leave you a few seconds to have a think what might be the cause there. That's assuming you haven't worked it out already, because it's pretty obvious, really. But I found the same thing. Here's the clue for you. I found the same thing testing another 8371. When I would put an 8372A in from another board, that would be fine. but these 8371s were touch sensitive, and I have seen this before, but it's ages ago and I'd just completely forgotten. And the answer is this pad down here. On Rev 6A board it's cut, which means that the A372A that ships with this is put into PAL mode. Yeah, if you short that, you get ground coming across there, and with an A372A that puts it in NTSC. Yeah, so if you've got a US model, you'll find that jumper's not cut. On a PAL 6A like this, it will be cut. But you'll have an 8372A, not an 8371. The difference, let me just mute the sound there. The difference, the 8371 on that pin, instead of it being PAL NTSC specific, you know, way to toggle the chip, it doesn't work that way. You've got a PAL version of the chip, the 8371, and you've got the NTSC version, the 8370. And that pad there, and the pin it goes to, puts it either in test mode or normal mode. So it was in test mode because it originally would have shipped with an 8372A. That is the issue. And of course that's not the entire issue. The white screen thing was the CIA. And obviously, you know, we needed to replace the socket to start with here, but it came to me with an 8371 on it. So I've just given everything a test, everything is working fine. I'm going to swap out these Shui are the caps here. They're always awful, and you can see it's battered up. There's what looks like a bit of discoloration down there. These do tend to leak, these do tend to, you know, the ESR tends to go over a period of time. They are the main smoothing caps, so it's always a good idea to swap these out. I might swap out that 470 as well while I'm at it. You don't generally need to swap out every single cap on these, but those main 2 or 3 caps there, you'd be stupid not to, as I have mentioned numerous times on videos. So we'll set a bit of solder there. May need to use the desolder station as well to get this off. And the other one is here. It's a bit wobbly, that one, actually. I can feel it wobbling. I think it's here. So the way I'm going to tackle this, actually, because they're so hard to get out, well, if you use the desolder station and set it pretty high, you're probably alright, but yeah, I'm just going to sort of pull one pin at a time and slide it out, and then try and unblock the holes. Yeah, it's coming out around that side. It's this side here, the ground. It's moving now. Almost out. That side again. That one's out, I think. There we go. So that's that one. We'll check it in the meter in a minute. Let's now do this one. God, that flux stinks. Yeah, it's freed on one side a little bit. Obviously don't wrench it off because you don't want to damage the pads. There you go, it's moving a little bit. You do have to alternate though, because the legs are fairly close together and it's obviously through the board a decent distance. That's out, I think. There we are. That's 2. But just have a clean around the top side here just in case there has been any leakage. But yeah, that's looking okay. You can, however, see some green there. Can you see that? So I think that one has leaked around there. It could just be corrosion that's got on there. Yeah, the pins look alright, so that's probably just something else. Got some brand new Panasonic FR series 3300s, same as what we're on here. As I've shown in other videos, later boards have, let's just check that is a ground there. Later boards have 1000 microfarad caps there, but I'd swap them for the 3300s personally. Yeah, I just wanted to check from a ground here to pads. Yeah, that's ground. That's not. It's beeping, but it's not. That's a dead short, the top one. So that's where's the cap gone now? Our ground wants to go towards the top side here. So it's worth checking things like that. The last thing you want to do is solder them on the wrong way around. Pressing it nice and flat onto the board here. Start with the positive side, because that's the easy one. and then we'll do the ground. Yeah, the iron temperature I've got 440 for these caps. That's still going to take a few seconds with this tip because this tip is too small. You want a big chunky tip when you're doing soldering on those caps like that. Certainly the ground side. That's alright. Let's just trim that down. And we'll just reflow to get a point. Yeah, these little bits of solder here will come off in a minute when I clean that up. Anyway, that's one down. While I'm here, I'll just stick a red dot on that, as I usually do. So it's obvious that one's been swapped, and I'll mark it accordingly later. And this one was ground to the right, so the ground is down here. I'll start with the ground this time. Just pressing the cap flat. Again, I need to give that some time. And that's what I did to desolder it. I just held it here for like 20 or so seconds, maybe 30 seconds, so I could feel this whole area warming up here. And then I used the desolder pump and it worked fine. Just unblocked it first pass. That's it. Just trim those off. And then again we'll just reflow to a point there. It just removes the excess solder and it just makes it look tidier. Well, that was really easy this time. That Heiko is fantastic for doing this kind of work, really. Thanks very much to Dermot Sweeney for providing that way back in 2019. There we go, that's not too bad. And that one as well. The flux around there was messy like that already from factory, but you can see it's coming off. That's not too bad. So testing those caps there, you may think that that's a good sign, 0.06. I actually think that shows those are well and truly screwed, actually. Because there's no way those caps would have had such a low ESR like that. But the capacitance is alright, so you know what, maybe that's not too bad. Maybe it's not had much use in its life, so I don't know, maybe it is alright, but yeah, I'm sceptical, actually. Again, that's really low. Slightly low capacitance. Questionable, I think, at this stage. Those, the meter is showing they're alright, but I wouldn't trust them. I really wouldn't trust them. This is the Rev6A schematics as well here, and we've got Agnes, so there's a few things to show here in terms of the VSync and HSync stuff. So you can see input, output. I actually think Agnes produces those. Yeah, I think Agnes produces those, and they go out to the CAAs, as I showed earlier. But the key thing here I want to show you is this down here. You can see it says NTSC/PAL test something, it says there, I don't know. But anyway, you've got that jumper that goes to ground. Yeah, so that's how you configure between NTSC and PAL using N8372. Now these are the Rev 5 Amiga 500 schematics, and just down here it says test, and there's a signal going to ground. That is the same pin as that one, pin 41. Yeah, I can just about read there, it says 41. So yeah, that's the issue. That, you know, the Agnes that was destined for the Rev 5 boards, an 8370 or 8371, was configured to test mode by pulling that pin to ground. It's interesting how it was like touch sensitive. You could move your finger around it and it would crash. Often it wouldn't even boot without your finger over there. It's bizarre, and it's because something was floating. So you've seen those two schematics there that explain that jumper, but why was it behaving the way it was? Well, you know, it's touch sensitive. You put your finger on there, it may or may not boot. You remove your finger, it often wouldn't boot. Sometimes you'd cause a crash just by moving your finger near it, and sometimes the opposite would happen. Your finger being a certain part of the fat Agnes there, it would start to work. And obviously the issue is here, that this was configured to, this particular board, the Rev6 here, was configured with this jumper open here, yeah? that puts in PAL. Now that's an interesting point, that on a number of videos where I've covered this upgrade here to, you know, put an 8372 into, I don't know, a Rev 5 or even a Rev 6 board, regards to the jumper, you need it to be open circuit, floating. And I had a number of people going, you can't have it flowing, that's bad, you know, it shouldn't be flowing, it'll be flipping state, it's bad practice to have a flowing signal. That is exactly how this is intended to work. That's how Commodore did it. It's either ground or it's floating, because there's an internal pull-up in the 8372. That's how this works. There's a resistor inside it, a weak, I don't know, 4K7 or 10K between this pin and 5 volts. So when you just connect this, that resistor leads a path to, you know, 5 volts and gives you a high. Yeah, you jump at this resistor here because it's a weak pull-up. Yeah, it's high value. The short here is 0 ohms. Yeah, the voltage swings right down this way to ground, and that's how it would be put in NTSC. But open circuit, it floats. The pull-up pulls it high. It's in PAL mode. Yeah, it really is that simple. So because this board had an 8372 on it from factory, that trace there was cut. Yeah, someone then removed that and went, oh, I'll stick an 8371 in there, that'll do. You know, oh, why doesn't it work? I don't know. And it's because it was floating here, and you know, it's not supposed to be here. It's supposed to be tied to ground. It was never designed to be floating. Yeah, on the 8371 or 8370. And that's the thing. So that's where the finger thing comes in. When you have a floating connection, there's no pull up or pull down, yeah, and it's just completely floating. It's high impedance, you know, input to it effectively. Then things in the environment, yeah, i.e. your finger, a little bit of capacitance, some charge nearby, can pull it one way or the other. It can, you know, as it sounds, it floats in the middle, but it can go up and down, up and down. And this is why it was touch sensitive to my finger. If you ever find a behaviour like that in a system, yeah, where you put a finger near something and weird things happen, something somewhere's floating. I'd go around with your logic probe, check all your inputs and stuff around a chip like this, and just see if you've got something rather than nothing. If you find a high impedance connection, that's something that needs further investigation. That could be your issue. So just a final test with the A500 here. We need a later version of Kickstart. It will start to boot with 1.3, but then comes up saying needs 204 or greater, I think, something like that. Yeah, the nice thing with a Rev 6A board like this, it will accommodate EEPROMs and things, but you know, this is a Maskrom. You can see that's loose, so you know what, that socket probably needs replacing. I'll do that within another part of the series. It'll just be a quick, you know, let's swap the socket on that. But that hopefully now should boot. Switch this on. Yeah, it's tilted a little bit here, but we should see some flashing here. Yeah, you can see the link top right for the repair of this A590. We fixed another A590 as well before that. You've got to remember we've got stock 68K CPU here, so it's a wee bit slow at booting. Yeah, there we go. Woohoo! Fantastic. We've got the 2 meg there. Well, just under 2 meg now. Some of it's been used by the A590, or from the A590 that's providing that. Oh, I forgot about this. This is the hard disk where the mouse moves at insane speed. It's a while since I looked at this drive. It came from Tom Meads. Let's just have a look to see what else is on this hard drive. Looks like we've got skid marks there. I'm not sure what that is. Let's try it. Oh, hang on a minute. Look at these things here. What's that? Oh my goodness. What have I come across here? Yeah, it's some sort of bulletin board thing, isn't it? Or maybe it isn't. Maybe that's an online racing thing, because I saw something about cars in there. That's a bit weird. Well, I've got a demo of Valhalla there. Let's see what that does. Oh, cool sound. Look how clear that is. That's amazing. That's super sharp. I can't believe how good the video is on that. That's amazing for RGB. Yeah, so I have no clue what I'm doing on this, if I'm honest. Maybe need the joystick and keyboard connected. Yeah, so it was a bad idea using that other drive because there's hardly any games on it. Let's use the A590 we fixed in another previous video. So I've got the SCSI 2SD here. It's looking a bit dusty, even though it's been inside an ESD bag, which is interesting. So yeah, everything looks okay connectivity wise. It's ages since I've used this one, so let's hope this works. Yeah, got a flash there, flash in here now. One thing I would say about booting from an original hard disk is you get audio feedback, don't you? You know, you can actually hear the drive. With this, you're just looking at the LED going, is it working? Well, it is, clearly, but yeah. Let's just close that. I haven't got the real-time clock and sensors and things on this one. So, a bit of bomb jack. Now, I think this is one of those lazy ST ports, if I'm honest. Because if you've got the ST, you'll know that it's identical. The graphics look the same, even the sound. The Amiga version could have been a bit better on this, I think. It's perhaps one of those games that could have an updated version if someone's inclined to do so. But yeah, that's working. Yeah, it's a wee bit slow as well. That's another telltale sign. It's a lazy ST port. Of course, you're supposed to get them in the order that the fuse flashes, aren't you? One thing I always noticed about this game, can you see how dark it looks? Yeah, I mean, it seems to be an intentional thing. They've gone with like a really dark palette. Not even sure if you're going to be able to see that with the low brightness level. And a wee bit of Toki here. So yeah, I've been playing this for a few hours, going around all the games I've got on this hard disk here. And it works fine. Not a bad version of Toki, this. Well, some people call him Toki, I don't know. Watched Jamie Morgan do some plays of this game. He's pretty good at it. He's good at most games, to be honest. But yeah, check his channel out. I've mentioned him lots of times. So colourful, this version, isn't it? Anyway, I am absolutely pants-eyed. Oh, God. So a huge thanks to William for sending this and the 500 plus that you'll see in the next video. So you can see I marked it up here, fixed 2021 partial recap. Yeah, this was done last year. So a quick summary, we had some missing chips, obviously. I think I put the ROM on there, got a ROM for that, and one or two other things were missing. But yeah, it had the Agnes on there, the socket was damaged up here, it's damaged up there, we put a new socket on. This was a bit green, it's looking a bit dull still there, I don't know if you can see that. You know, that I think came from a 500 plus, because that's the area that gets super corroded on a 500 plus. And you know, these parts just got back filled to this board as something else was fixed. Maybe this came from the 500 plus you'll see in the next video. The CIA over here was an issue as well. Yeah, that had nothing to do with it. And obviously replace these as par for the course kind of thing. I really perhaps should replace that 470. And you can see, hopefully, I straightened these pins out here. So yeah, no marks or anything on those. Those are fine. Yeah, I put the little nuts in a bag here. So yeah, at some point this will probably get back fed into a case. I've got a case, and I think this board will go into that, and it'll be part of another video. I marked it here S&P OK. I always do this. Tested the seal, parallel ports and stuff, and obviously I've tested everything. You know, the joystick, the mouse, the sound, the timers and things. I've done full diagnostics with diagram, all the same stuff that you've seen throughout this A500 series here, and all the other Amiga repairs I've done. I've tested everything on this. So it lives to see another day. Yeah, so thanks again to William. I hope you found the video interesting. I will catch you in the next video.